Kamchatka is witnessing a sequence of rare, perilous events that has alarmed scientists around the world. The sixth strongest earthquake in human history roused dormant forces that had slept for centuries. 7 Kamchatka volcanoes awakened in unison. A volcano silent since the 15th century released a column of ash 6 kilometers high into the sky. Klyuchevskoy, the highest active volcano in Eurasia, began spewing lava flows that ran about 3 kilometers down its flanks and threatened the region's largest glacier. Yet this was only the beginning. Some observers insist the danger extends beyond a local catastrophe, potentially triggering activation of the entire Pacific Ring of Fire. More than 400 volcanoes scattered across the Pacific could react to the Kamchatka impulse. Scientists record an elevated probability of eruptions along a 40,000-kilometer arc from Russia to Chile. Over 100 volcanic peaks are now at risk, and 1 billion people may be affected. Geologists warn that if as few as a dozen major volcanoes erupt simultaneously, the planet could enter a volcanic winter for several years. But why now? What would be Russia's fate if lava melts Kamchatka's glaciers? And could this spark a domino effect across the Ring of Fire? On the 30th of July 2025, the residents of Petropavlovsk-Kamchatsky woke to alarms, unaware that within hours they would witness events unseen on Earth for nearly 3 centuries. At 7 o'clock in the morning, the ground shook with such force that a seismic wave circled the globe. This quake proved to be the 6th strongest in human history. Tsunamis up to 4 meters surged the Kuril Islands, and waves reached the shores of Japan, Chile, Peru, Ecuador, and Mexico. But that was only the opening act. One after another, Kamchatka's volcanoes stirred. First, Klyuchevskoy, the tallest active volcano in Eurasia, bloomed with a blood-red glow as rivers of molten lava crept down its slopes, threatening one of the region's largest glaciers. Yet Klyuchevskoy was only the vanguard. On the 3rd of August, an eruption of Koroshennikov, dormant since the 15th century, shattered the silence. 6 centuries ended as ash rose to 6 kilometers. The director of the Institute of Volcanology and Seismology, Alexei Ozerov, did not hide his professional exhilaration. What we were witnessing, he said, was a rare parade of volcanic eruptions. If records are correct, such a display last occurred in 1737, when Kamchatka also faced a magnitude 9 earthquake. 7 volcanoes erupted simultaneously. In addition to Klyuchevskoy and Koroshennikov, Avachinsky, Kambalny, Bezymennaya, Karymsky, and Mutnovsky joined the sequence. Some lay dormant for decades, others for centuries, yet a recent quake proved the trigger that woke these subterranean behemoths. Mutnovsky, once a tourist magnet, is now strongly discouraged to visit, as satellite imagery reveals a thermal anomaly signaling magma simmering deep below. The southernmost Kamchatka volcano, Kambalny, began to emit a sinister hum, audible for tens of kilometers. Yuri Demenchuk, head of the Volcanic Observatory with 50 years on Kamchatka, says he has never seen such a mass eruption. Yet the most alarming point is that this may be only the beginning. Kamchatka sits on the Pacific Ring of Fire, a belt spanning 40,000 kilometers that encircles the Pacific Ocean. Here reside 75% of Earth's active volcanoes and 90% of the planet's earthquakes. Scientists now wonder whether this volatile ring could awaken its deadly fires along its length. The Ring of Fire is not a poetic image, but a concrete geological reality that could become a nightmare for a large portion of humanity. From Russia and Japan to the western United States and down to Antarctica lies a chain of 425 volcanoes, 3 to 4 of Earth's active volcanoes. In the wake of the Kamchatka megaquake, researchers worldwide have watched with anxious anticipation. Geologist Michael Manga of the University of California, Berkeley, voices grave concern, noting that arcs in Chile, the United States, Japan, Indonesia, and Kamchatka tend to erupt after major earthquakes. The mechanism is straightforward. When tectonic plates jerk abruptly, they release energy as seismic waves that travel through the crust. These waves can raise stress at magma sources thousands of kilometers away and may crack the surrounding rock or open conduits for magma to ascend. Even more ominous, the shaking can rupture gas pockets inside magma, making it more mobile and unstable. Some scientists believe seismic waves can radiate from the epicenter across hundreds or thousands of kilometers and shake volcanoes already near eruption. The Kamchatka quake has already raised the probability of eruptions along the ring by 12%. That may sound small, but on a planetary scale, it dramatically heightens risk for hundreds of millions of people, and the elevated threat could endure for months to years. In the zones of greatest danger lie more than 100 volcanoes across Russia, Japan, the Philippines, and Indonesia. These regions already show alarming signs, with elevated activity recorded off Alaska. The Hawaiian volcano Kilauea, already among the world's most dangerous, is also under close scrutiny. The most troubling and plausible forecasts warn of simultaneous eruptions from several major volcanoes. If that happens, humanity could be thrust into a volcanic winter, as millions of tons of sulfur ash would reach the stratosphere, blocking sunlight and cooling the globe. The parallel with history is sobering. In the year 1815, the Tambora eruption in Indonesia produced a year without a summer, cooling the northern hemisphere and triggering crop failures and famine in Europe and North America. Back then, only one volcano erupted. What would occur if dozens awakened at once? Russia, with its harsh climate, would be hit particularly hard, and the Far East could face 30-meter-high tsunamis that would wash away coastal cities like Vladivostok, Sakhalin, and the Kurils. Scientists do not rule out that current Kamchatka activity could be a trigger for a far larger catastrophe, while elsewhere the world watches a belt of Russian volcanism, and underground there are already new foci forming. History repeats itself with a troubling regularity, and Kamchatka's events stand as a stark example. In 1737, exactly 288 years ago, a magnitude 9 earthquake struck the peninsula, awakening many volcanoes. The renowned explorer Stepan Koroshennikov, after whom one of the awakened volcanoes is named, wrote that fire breathed from the summit to the base and a thick cloud rose and rolled toward the sea. The seismic winter continued into the spring of 1738, and the homes of Kamchatkan indigenous people suffered grievously. What unsettles scientists most is the striking parallels between 18th century events and today. Dr. Alexander Vikulin, a seismologist, anticipated in the 1990s that today Petropavlovsk would tremble at most 8, and that around 2008 plus minus 10 years, a stronger quake up to 10 would occur. His forecast was grounded in the 1737 catastrophe and the cyclicity of seismic processes. Are his predictions beginning to come true? Today, Kamchatka records dozens of aftershocks daily, and in the early days their number surpassed 680, with magnitudes from 3.5 to 6.5. This is not merely the echo of the main shock, but a sign that the peninsula's crust remains in extreme instability. Notably, several quakes once treated as foreshocks have now been reclassified as aftershocks of the main event. 10 days before the megaquake of 8.8, a magnitude 7 tremor struck. Authorities reassured residents that the worst was behind them, yet that reassurance proved to be only a prelude to disaster. Distinguishing foreshocks from main shocks is extraordinarily difficult, and science can detect events but cannot predict them with certainty. Even in technologically advanced Japan, with hundreds of laboratories monitoring seismic networks, warning people days ahead of an impending quake remains beyond reach. This underscores the importance of studying historical analogs. The Kamchatka region now faces what could be its most dangerous phase in 3 centuries, for geological cycles run in centuries. Danil Chebrov of the Kamchatka branch of the Geophysical Service warns that we were lucky with the recent quake only because it followed a best-case scenario, and there are no guarantees for the next time. Of particular concern is the behavior of the Koroshennikov volcano, where summit and flank eruptions began simultaneously, signaling potent activity inside the volcano. There were numerous coincidental signs. On the same day Kamchatka's volcanic activity intensified, an earthquake of magnitude 5.1 struck off the coast of Myanmar. Myanmar is not officially part of the Pacific Ring of Fire, but the troubling synchrony suggests deep mantle processes influence a much larger area. For the global scientific community, Kamchatka events have been a rare gift, offering the chance to observe unusual geological processes in real time with the latest technologies. Dozens of scientists watched monitors, analyzing streams from seismic stations, satellites, and underwater sensors, capabilities far beyond those available during the Japan quake of 2011 or the Kamchatka quake of 1952. The subduction mechanism remains a focal point, since it links earthquakes and volcanism as 2 facets of one planetary process. Satellite observations revealed striking details. The eruption began simultaneously from the summit crater and the flank, indicating strong deformation within the volcano. The ash plume stretched some 75 kilometers to the east, reaching up to 6 kilometers above sea level. Thermal anomalies at Mutnovsky showed a sharp rise in surface temperature, implying magma had risen much closer to the surface than usual. Researchers also noted the lava flow behavior at the Klyuchevskoy volcano. The lava flow, already 3 kilometers long, advances toward Bogdanovich Glacier. If the fractured lava reaches the glacier, a catastrophic event could unfold, spawning lahars, mud flows of water, ash, and debris. The only road linking Kamchatka's northern settlements with Petropavlovsk-Kamchatsky is at risk. Melted glacier could unleash lahars that erode this essential transport artery. For residents, this would be a disaster, isolating communities for an uncertain period. International air travel is also endangered. While major transcontinental routes avoid Kamchatka, ash plumes can drift hundreds of kilometers. Local trouble may pale beside global risks. Geologists worldwide monitor with concern, aware Kamchatka could trigger the Pacific Ring of Fire. Indonesia stands out, at the junction of 4 tectonic plates, hosting Krakatoa and Toba, whose eruption nearly wiped out humanity. Japanese volcanologists are on high alert. Mount Fuji has shown unrest in recent years. Any eruption of this peak would threaten Japan and ripple through the world economy. Scientists model grim scenarios. Simultaneous eruptions of several large volcanoes could trigger a volcanic winter lasting 2 to 5 years. Kamchatka's activity persists. Daily ash emissions, lava flows down slopes, and hundreds of underground tremors recorded by seismic stations. Experts do not rule out the awakening of additional volcanoes in the coming months. humanity is witnessing a rare third geological surge of volcanic activity in almost 3 centuries. This reminds us that Earth remains unpredictable, capable of abruptly altering history. Yet the most striking finding concerns the synchrony of processes. Researchers find that activation of different volcanoes follows a specific sequence tied to the spread of seismic activity from the epicenter. This supports the idea that subterranean processes form a single interconnected system,